Hi, welcome to my channel. Today in this lesson, I'm going to discuss questions related to electric field from Edexcel past papers. I made a worksheet from different Edexcel past papers and uploaded that worksheet in Google Drive. Before watching this video, please download it. All the instructions how to download are given in the description of this video. So first question from my worksheet, it's in the Google Drive, you can download it from there. First question, calculate the electric field strength at a distance of 5 centimeter from the surface of a positively charged sphere. Okay, so according to this question, first question, there's a spherical conductor. Okay, it's a conducting sphere that carries a charge of 34 nanocoulomb, positive 34 nanocoulomb. And the diameter of the sphere is 12 centimeter. So radius is 6 centimeters. So the question is, find the electric field strength at a distance of 5 centimeter from the surface. So I can name that point P, that is 5 centimeter from the surface. Okay, we know that we can assume all the charges are concentrated at the center of the sphere. Okay, it's a conducting sphere. What's the reason? Why do we assume like that? Actually, we normally say Gauss law, but in Edexcel, the word Gauss law is not in the syllabus. So we can explain like this. What's the reason we assume all the charges are concentrated at the center? We can explain like this. If we consider a if we consider a sphere which is carrying positive charge, and if the charge is uniformly distributed on its surface, and if they ask to draw the electric field lines, we will draw like this. The electric field lines, I can draw any number of field lines, but if I draw 4 electric field lines, it will be radial. Radial means the electric field strength decreases when the distance increases. That type of field is called radial field. So in this radial field, there is no electric field inside the conductor. Yeah, the charges won't experience any force, so no electric field strength inside the conductor. And if I extend these lines, the electric field lines, if they are extended, they will meet at the center. Actually, there is no electric field inside, but if I extend the lines, they'll meet at the center of the sphere, conducting sphere. So that's the reason in Edexcel we say we can assume the whole charge which is distributed evenly on the surface can be assumed as it's located or it's concentrated at the center of the sphere, right? So if I assume like that, I need to find the electric field strength at a distance of 11 centimeter from the center O. So we know the equation E equal KQ over R squared. K is 8.99 10 to the power 9, but we can use 9 into 10 to the power 9. Q is 34 nanocoulomb, so 34 into 10 to the power minus 9 over R squared from the distance, that is 11 centimeter, so 0.11 squared. So if you solve this, you will get the answer for the first question. So the electric field strength will be equal to 25,300 Newton per Coulomb. That's the answer for the first question. Okay, so this is the second question in my worksheet, page number 1, question number 2. It says the photograph shows an arrangement for investigating charge known as the shuttling ball. So that's a photograph is given in the question paper. So what they are saying is X and Y are two metal plates. X is connected to positive terminal of a DC power supply and Y is connected to negative terminal. So there will be electric field in the region between the plates. And there's a metal ball, actually it's a ball coated with metal on its surface, is hung by using a long string which is not conducting string, right? And if they're saying the word long, I'll tell you why that word is used, long string, right? And it's kept between the region between the parallel plates. Actually, what they are saying, when the metal coated ball, when it touches the positive terminal, it will be positively charged due to induction. So if it is positively charged, then it will be attracted by the electric field in the region between the parallel plates. So it will accelerate towards plate Y. And when it touches the plate Y, it will become negatively charged and it will accelerate again towards plate X. Is it? So the electric field in the region is fixed because the distance between the plates is fixed, E equal V over D. So the electric field strength will be uniform in the region between the parallel plates. Is it? So they are saying that, and they are saying due to the charge of the ball, the existing electric field will not be disturbed. So already there is electric field due to the parallel plates, oppositely charged parallel plates. So that electric field will not be disturbed by the charge of the metal sphere. So that's the data given. You can read it from the worksheet. Please download it from the Google Drive. All the instructions are given in the description of this video. Right. So A part of the question 2, A part, first part says, sketch field between the plates on the diagram below. So they are giving the diagram like this. So question number 2, second question, A part, first part, the metal plates are given like this and they are naming it X. This is Y and they are saying this is positive, this is negative. They asked to draw the field pattern. We know oppositely charged parallel plates, in the region between them there will be a uniform electric field, and you know how to show the uniform electric field. You should draw parallel lines with equal space. At least 4 lines you can draw, but if you want you can draw more than 4 lines also. So that is the uniform electric field, is it? Lines should be drawn with equal space and they should be parallel to each other. So that's the answer for the second question, A part, first part. Second question, A part, second part of the A part. So they are saying, explain why the charged ball experiences a horizontal force of constant magnitude. Okay, you should explain why it is a constant magnitude while it is between the plates. So first you should say, the electric field strength in the region between the parallel plates is given by E equal V over D. Since the distance between the plates is fixed, they are giving a value, the length, actually the width is given in the next part, but we know the gap between the parallel plates is fixed and potential difference between the plates also fixed. So the electric field strength in the region between the plates is uniform and that is constant at all points. First you should say electric field strength is constant because it's a uniform field and it will be the same at all region of the all the part of the region between the parallel plates. Then you should say the electrostatic force acting on the metal ball is given by F equal QE. Since the metal ball is carrying always the same magnitude of charge. That is actually practically that might happen because when this ball touches the plate X, it's getting positive charge. It will be attracted by the negative plate. When it touches the plate Y, if it gets the same magnitude of charge only, it will have the same magnitude of force. So we should say that one. Since the ball always carry same magnitude of charge, the sign of the charge will change. When it touches the plate X, it will become positive. When it touches the plate Y, it will become negative. But the magnitude of the charge carried by the ball is constant. Therefore, the electrostatic force is also constant. Okay, so question number 2. B part, I can summarize by using this diagram. So they are saying after touching the plate Y, the ball is accelerating towards plate X. Obviously, it will have negative charge, so it will accelerate towards the positive plate. Yeah. So these are the data given. They are giving the mass of the ball is 2.7 grams and the distance between the parallel plates is 9.5 centimeter. The potential across the parallel plates is 5000 volt and the charge carried by the ball is 11 nanocoulomb. Obviously, certainly it will be negative charge because after touching Y, it's moving towards plate X means it should be negative charge, right? They ask you to find the acceleration of the ball. So we know that F equal QE and E equal V over D. And also we are going to use F equal ma, the Newton's second law, because when you think about the free body force diagram of the ball, it will have weight downwards and the force will be, the electrostatic force will be in horizontal direction because electric field lines are horizontal, already we showed it. So the weight won't have, weight is in vertical direction, so the vertical vector won't have any horizontal component. So the resultant force on the ball in horizontal direction is only due to the electrostatic force. I can say Fe. Fe stands for electrostatic force. So by using these equations, I can find the acceleration. So I can say Fe, that is equal to charge of the metal ball is 11 nanocoulomb. I don't need to use the negative side. 11 into 10 to the power minus 12. 10 to the power minus 9 nanocoulomb, 10 to the power minus 9. And the electric field strength equal V over D. So potential difference, we know that is 5000 divided by the distance between the plates, 9.5 centimeters, so 9.5 into 10 to the power minus 2, right? So F equal QE, E equal V over D. Everything I used it because I already showed the equation. That is equal to MA. If equal MA, because that's the only force in horizontal direction. So the mass of the ball is given as 2.7 gram, convert to kilogram. So divide by 1000 or 10 to the power minus 3 times A. So find the acceleration. So you will get acceleration that will be equal to 0.214 meter per second squared. That's the answer for B part, question number 2. Okay, that's the answer for the question number 2, B part, first part. Okay. Okay, now question number 2, part B, second part. So these are the information given. We already know the distance between the parallel plates, that is 9.5 centimeter, right? And the diameter of the ball is given in this part, that is 4 centimeters. So the ball is moving from plate Y to plate X, right? So what distance will it move? The distance the ball going to move will be this much. So that will be how much? Say this is 9.5. The diameter is 4 centimeters. So when this end touches the plate X, the motion will be stopped. Then it will bounce back, isn't it? So that distance is going to be 9.5 minus 4. That will be 5.5 centimeter. The question actually in this part B, second part, the question is they ask you to find the momentum of the ball when it just reach the plate X. Okay, they ask to find the momentum of the ball when it just reaches the plate X. Okay, so if I want to find the momentum, we know momentum equal mass times velocity. Mass of the ball already given in the previous part. I need to find the velocity or the magnitude of the velocity, the speed I should find it. How can I find it? I know the equations of motion I'm going to use. I know the acceleration is constant. We already showed it. Yeah. So we know the acceleration. We know the distance the ball that is going to move from Y to X, that is 5.5 centimeter. So I can use in this direction V square equal U square plus 2AS to find the speed when it just reaches the plate X. So the initial speed is 0 because it's leaving the plate y at rest from rest. So u is will be 0 plus 2 times acceleration. We found it in the previous part, that is 0.214 into the distance that is going to move is 5.5 centimeter. So 5.5 centimeter means I should convert to meter, that is 5.5 into 10 to the power minus 2. Solve it, you will get the magnitude of the velocity, that is the speed, that will be 0.15 meter per second. So momentum of the ball just before it touches, the momentum P equal mv, that also towards left. That is mass of the ball. We know that already we found it. The mass of the ball is 0.0027 is 2.7 grams. So I can say 2.7 into 10 to the power minus 3 convert to kilogram, and the speed is 0.15. So when you solve, you'll get the momentum, that will be 4.1 into 10 to the power minus 4 kilogram meter per second. Okay, so in this question, some students have confusion because they argue, it's something like a simple pendulum, is it? So it's actually oscillating between x and y. So when you think about oscillation of a simple pendulum, it will not move on a horizontal path, is it? So the ball will move on part of a circle, segment of a circle. We know the oscillation is like this. So if the plates are here, when the ball reaches the plate X, it won't have velocity in this direction. It's going to have it at an angle. That's the reason in this question they mentioned in the previous page, page 1, I read it when I was starting this question. So it's mentioned that a ball coated in conducting material is suspended on a very long insulating thread. Okay, so that statement is important. It's a very long insulating thread. So that means compared to the gap between the plates, this length is very large. So if the length is very large, even though actually it's moving on a curved path, but when we consider the close-up region, the motion looks like almost straight line. Actually, it's taking a longer segment of a circular path, but when we consider smaller region, it looks like a horizontal motion. So the curved path, we don't need to consider. We assume the ball is moving exactly in horizontal direction in the region between the plates. The reason the length of the string is very large compared to the gap between the parallel plates. Okay, question number 2, part B, third part. They are saying the ball is in contact with the plate X for 0.95 seconds. So the contact time is 0.95 millisecond. And they are saying calculate the average force acting on the ball during this contact time. Assume that the ball hits the plate and leaves the plate at the same speed. So that means we already found the momentum of the ball just before collision. So since it's bouncing back away from the plate X at the same speed, they asked to assume that way, the question. The momentum after collision also will be same as momentum before collision. So initial momentum, final momentum, both will have the same magnitude and they will be in opposite direction. So if they ask to find the force acting on the ball, so if you draw the diagram, the force acting on the ball will be towards right during collision with the plate X. So we know the force F equal rate of change of momentum. We know that. We learned that in momentum. So rate of change of momentum means final momentum minus initial momentum. I know the force on the ball is towards right, so I'm taking towards right is positive. Final momentum is also towards right, so I'll write it PF minus initial momentum. So when I consider initial momentum, that is towards left, opposite to the sign, I took it as positive. So that should be minus PI. okay, divided by time. So it's going to be PF plus PI over T. Right, I know the PF, PI both have the same magnitude, so I don't need to add them. I can just multiply 2 times 4.1 10 to the power minus 4 divided by the contact time is 0.95 millisecond 10 to the power minus 3. So solve it, you will get the force experienced by the ball during collision. That will be 0.86 Newton. That's the answer for B part. Third part, question number 2. Okay, question number 3. This question is about a Van de Graaff generator. You know, it consists of a metal dome, okay, a hollow metal sphere, and it's connected to a rubber, okay, a tape. You can charge the dome by using the friction. Actually, it's an induction due to electrostatic induction. And they are giving this diagram also. That is the electric field after the dome is charged. The electric field pattern will be like that. It's given in the question. So question number 3, page number 4 in my worksheet. You can download it from the Google Drive. Please go through the description part of it. All the instructions are given. Okay, so they are saying the photograph shows a Van de Graaff generator used in a school laboratory. And they are saying the dome may be treated as a positively charged sphere with a charge distributed evenly on its surface. Yeah, that's the reason they gave this diagram. And they are saying electric field outside the sphere is shown like this, and there is no electric field inside. So first part, first part of question number 3 is suggest why there are no field lines inside the sphere. Okay, actually, you know, after you charge it, the charge stays on its surface, and that is static charge. Electrostatic, we call static charge. So that means they are not in motion. So if the charges are not in motion, inside the dome, all the charges are, there are no charges inside. So if there are no charges inside the dome, there is no force acting on the charges. There are no charges, so no force, and all the charges are at rest. So since all the charges are at rest, the strength of the field must be equal to 0 according to F equal QE. The force acting on the charge must be equal to 0. So we can say like this, since there's no force acting on the charge, the electrostatic force acting on the charge is equal to 0. We know F equal QE, and all the static charges are at rest. Therefore, E must be equal to 0. That's the answer we can give for the first part, why there is no field inside the dome. Right, second part, this axis is given. Second part, this axis is given, incomplete. They asked to draw the electric field strength against distance from the center of the sphere. So there's a dotted line that represents the radius of the sphere. And they asked to draw the shape of the electric field strength against distance from the center graph. We know inside the sphere there is no electric field strength. The electric field strength on the surface is given by E equal KQ over R square. R is the radius of the sphere. What's the reason? I already told that in the previous question also. We can assume all the charges are concentrated at the center. And if I say the radius is capital R, the electric field strength on the surface is given by KQ over R square. So at that point, the electric field strength is KQ over R squared. And we know that the electric field strength follows inverse square law. So the graph will be inverse square law. According to that, the graph will decrease like that. I can draw this as a vertical line. So this is the answer for question number 3, part A, second part. Okay, question number 3, part B. So question number 3, part B. So they are giving a capacitance. You know, how can it form a capacitance? Actually, just one dome. I didn't have any video regarding capacitance. I'm going to do it later. But anyway, you would have learned that at school. You learned that parallel plate capacitor. So that means parallel plate capacitors means there should be two plates, and most of the students have idea. So there should be two metal conducting plates in the region should be filled with dielectric material. Yeah. So one plate should be positively charged and the other one should be negatively charged. That's the idea you have. So when you say capacitance of the metal dome means, what is the next plate? The next plate is the earth. Okay. So we assume the potential of earth as zero because earth can accept any amount of charge as well as it can give out any amount of charge. You can think like this, during lightning, several billions of Coulomb of charge strikes the earth, but in a fraction of a second, if you test a point where the lightning hit on the ground, on the earth's surface, if you test it, it will be zero. That means the earth will accept any amount of charge falling on it and it can give out any amount of charge also. So normally we take the potential of earth as 0 volt, right? So actually here the capacitance, when you consider the potential difference we should accept between the earth and the ground. Okay, so we can form a capacitance in the region between the surface of the dome and the earth. Okay, so I hope you understood that, because students normally get confused because they learn capacitance means there should be two metal plates. So when you consider a dome and they are saying in the question the capacitance of the conducting sphere of radius r is given by C equal 4 pi epsilon naught r. This is the capacitance of the metal sphere. So you can ask, what is the next plate? So the next one is the earth, right? Okay, so the question is, the dome of the Van de Graaff generator behaves as a conducting sphere of radius 12 centimeter. And the charge on the dome is 1.5 10 to the power minus 6 Coulomb, that is 1.6 microcoulomb. Calculate the potential difference between the dome and the earth. See, now they're asking potential difference between the dome and the earth. That's a question, because when you think about capacitance of a dome means, a sphere means, that should be relative to earth. These are the two metal plates like that you have to imagine. Okay, so all the data given, so I can find the capacitance. C equal 4 pi epsilon naught r. The value of epsilon naught is given in the data sheet. So 4 pi into 8.85 10 to the power minus 12. R is 12 centimeter, the radius. So 12 into 10 to the power minus 2 meter. So find the capacitance. So the capacitance will be equal to 1.33 10 to the power minus 11 farad. Then use the equation Q equals CV and find the V. There's a question of potential difference between the plates. Normally we learn in capacitor. So here the potential difference between the dome and the earth, but the potential of the earth is taken as 0 because it can accept any amount of charge and it can give out any amount of charge. So Q is given as 1.5 10 to the power minus 6. We found the capacitance 1.33 10 to the power minus 11 times V. Find the V. The value of V will be 1.1 10 to the power 5 volt. That's the answer for the B part, first part. Question number 3, B part, first part. Okay, question number 3, part B, third part. Part B, second part. They are saying the dome of the Van de Graaff generator is connected to earth through a resistor of resistance 9.1 10 to the power 11 ohm. So the question is, calculate the time taken for the Van de Graaff generator to lose 70% of its charge. Okay, so we have equation in capacitance. We learned that Q equal Q naught e to the power minus T over RC, where RC is called time constants, resistance, the total resistance of the circuit, yeah, where through which the charge is flowing. C is the capacitance. Okay, what does it mean? What's the meaning of this equation? At t equals 0, you know t equals 0 means initially. Initially, if the charge of the capacitor is Q naught, later, at time t, the charge remaining in the capacitor is given by Q equal Q naught e to the power minus T over C. That means when you are discharging a capacitor through a resistor, total resistance of the circuit is capital R. So imagine there's a switch. Initially, it consists of charge Q naught. So now you are switching on the circuit. So when you switch on, from that time, later at time t, the amount of charge remaining in the capacitor is given by Q equal Q naught e to the power minus T over RC at time t. Okay, so here they are saying the time taken, calculate the time taken for the Van de Graaff generator to lose 70% of its charge. So when it loses 70%, the charge remaining in the capacitor will be 30%. So 30% charge of Q naught means 0.3 Q naught is remaining. Is it? That's the initial charge. What's the time taken for what's the time taken to drop to 30% of its initial charge? So e to the power minus T over RC. So Q naught will get cancelled. So you know 0.3 equal e to the power minus T over RC. You can invert. Anyway, it's maths now. Now you can say e to the power T over RC is equal to 1 over 0.3. Take both side ln. If you take both side ln, T over e to the power T over RC equal ln 0.3. So you know when you take ln e to the power T over RC, it will become T over RC equal ln 0.3. So T equal RC ln 0.3. We know the resistance, that is 9.1 10 to the power 11. The capacitance, I'm cross multiplying. So the capacitance, we already found it. Capacitance, okay, it's given actually. 1.5. Sorry, we found the capacitance. We found the capacitance as 1.33 10 to the power minus 11 farad into ln 0.3. Solve it, you will get the time. So the time will be 14.6 seconds. Okay, there e to the power T over RC is 1 over 0.3. Take both side ln. It will be ln 1 over 0.3. Okay, I earlier wrote ln 0.3. This ln 1 over 0.3. Both side I am operating with natural logarithm. So T over RC, because ln e to the power T over RC will become T over RC equal ln 1 over 0.3. So make the T subject, cross multiply. R is 9.1 10 to the power 11. Capacitance, we found it in the previous part, 1.33 10 to the power minus 11 into ln 1 over 0.3. So that's the answer. Okay, this is the question number 4. It's about electron deflection tube. This diagram is given in the question. It's on my page number 6. You can download the paper from the Google Drive. All the instructions are given in the description of this video. Right. So the first part, the electron gun consists of a hot metal filament and positively charged anode. Explain how this produces a beam of electrons. So if I draw a block diagram, normally we draw a block diagram like this, is it? We normally draw, this is the cathode, this is the anode, there will be a small hole, we leave it, and this is the heater, And we normally show this as a negative plate and this as a positive charge, and we name this as high voltage, that is 2.1 volt. So this is cathode, this is anode. Electron will be emitted from cathode due to thermionic emission. You know, thermionic emission means when a metal such as tungsten is heated, electrons absorb the thermal energy. They vibrate and they will be released. You can say electrons are emitted due to thermionic emission. So here in this question, electron gun consists of a hot metal filament and positively charged anode. Explain how this produces beam of electrons. Careful, beam of electrons. So beam of electrons, continuously the electrons are emitted. So they are going to be accelerated from cathode to anode by the electric field created by this high voltage. So if you think about the electric field, that will be from positive to negative. This is going to be positive, this is going to be negative. The field lines will be this direction. They are uniform electric field. So you know negative charges such as electrons will accelerate opposite to the direction of field line. So the first part answer, A part, question number 4, A part, we can say electrons are emitted due to thermionic emission. Then you can say these electrons are accelerated by the electric field from cathode to anode. That's the answer for the A part. B part, the potential difference between the hot metal filament and the anode. So this is the anode, hot metal filament. This is the cathode. The potential difference is 2.1 kilovolt. The question, calculate the velocity of the electrons as they leave the electron gun. So this is the electron gun. Beyond it, they are going to enter into this parallel plates. So actually in this electron deflection tube, both are as a one set. So after that, the electrons are going to enter in the region between the oppositely charged parallel plates. So the electrons will deflect. Okay, depending on the potential. If it is positive plate and this is negative plate, electrons will deflect upwards. If this is positive plate, they will deflect downwards. Right. But the question is, what's the speed when they leave the anode? So I can use the work done, conservation of energy. I can say work done by the electric potential. Work done by the electric potential is equal to gain in kinetic energy of the electron. So work done by the electric potential, W equal QV. Q is the charge of the electron. Gain in kinetic energy, half mv squared minus half mu squared. So here we should assume the electrons are released from cathode from rest. So we should take U equals 0. So in this question, they didn't say anything about it, but otherwise we can't answer this question. We assume the electrons are released from cathode from rest. Charge of the electron 1.6, 10 to the power minus 19. Potential difference between the parallel plates, cathode and anode, 2.1 kilovolts, so 10 to the power 3 equal half into. This is the mass of the electron, gaining kinetic energy of electron. So mass is given in the data sheet, 9.11, 10 to the power minus 31, v squared minus 0. Solve it. You will get the speed of the electron when it enters the anode. So the speed will be 2.72, 10 to the power 7 meter per second. Okay, question number 4, part C. This is given as a photograph. The electron beam is bending towards upper plate. So that means we know that electron will be attracted towards positive plate. We can argue like that, or electron will experience electrostatic force opposite to the direction of field line. Is it? Either way we can explain. So that means opposite to the direction of field lines means electron is experiencing force upward direction. That is, the electrostatic force means the electric field line should be opposite to the direction of force acting on a negative charge. So the electric field line should be downwards. Is it? So the question, They gave a parallel plate and they asked to, on the diagram below, sketch the electric field between the plates. So we know that electron is experiencing force upward direction. I can say we should know that always negatively charged particles experience electrostatic force opposite to the direction of field line. So the field line should be downward. Or I can say, since electron is a negatively charged particle, it is attracted towards positive plate. So this is positive, this is negative. And we know the electric field lines are always from positive to negative plate. So the field lines we should draw with even space, equal space, parallel lines, because it's a uniform electric field. Okay, that's the answer for part C. Part D, the potential difference of 550 volt is applied across the plates. So that means they are saying this potential difference is 550 volt and distance between the plates is 5 centimeters. So this distance between the plates is 5 centimeters. The question is, show that the electrostatic force on an electron between the plate is about. So that means approximate value 2 into 10 to the power minus 15 Newton. So that's nothing. That is part D part. Okay, I'm answering now part D, question number 4, page number 7. So I can say F equal QE. We know the equation, and E equal E over D for the uniform electric field. So the question is electrostatic force. So charge of an electron is 1.6 10 to the power minus 19. E equal V over D. Potential difference is 550 over the distance is 5 centimeter, means 0.05. Solve it. You will get the answer. That will be 1.76 10 to the power minus 15. We have to show that approximately 2 into 10 to the power minus 15 Newton. Okay, that is question number 4, part D, first part. We found the force acting on an electron. Okay, question number 4, part D, second part. They are saying electron is entering into the region between the parallel plates at a speed of 2.2 10 to the power 7 meter per second. So since it's entering into the region parallel to the plates, at that moment when it enters, its vertical component velocity will be equal to 0, because we know horizontal vector has no vertical component. The question is, when it travels 10 centimeter parallel to plates, what will be its vertical displacement towards the positive plate? So I put it as h, the height, or whatever you can put, even d. So inside the plate, parallel to the plates, when it travels 10 centimeters, what will be its displacement towards the positive plate? That's the question. So something like projectile motion, what you learned in mechanics, right? So I can find the time taken to complete horizontal, sorry, I can't call horizontal, actually I should say, I can find the time taken to complete a displacement of 10 centimeter parallel to the plates. That means I'm considering the distance 10 centimeter perpendicular to the field lines. So I drew the field lines like this. So the electron is bending like this, means when I consider horizontal direction or parallel to the plates, means that is perpendicular to the field line. So there is no component of field line parallel to the plane, right? So there's no electric field parallel to the plane. So there's no force parallel to the plane. So there's no acceleration parallel to the plane. That will be useful to find the time taken to complete 10 centimeter by using equations of motion. So I can use horizontally. That means I'm saying horizontally, but actually it's parallel to the plates. S equal ut plus half at squared. S is 10 centimeters, so 0.1 meter. The speed when it enters into the region of the plates is 2.2 10 to the power 7 times t plus half parallel to the plates. I'm using this equation. There is no field, so no acceleration. So you can find the time. So time will be equal to 4.55 10 to the power minus 9 seconds. That's the time taken to complete 10 centimeter parallel to the plates. So I know the electrostatic force that is upwards. Actually, I can say towards the plate. The previous part, I found the electrostatic force that is towards the positive plate. So I can use towards the positive plate F equal ma. So the resultant force is it. So when you consider the electron, it has electrostatic force. I told the weight is negligible. Weight of a gas molecule, weight of a particles such as electrons, protons, alpha particles, very small. So I don't need to consider the weight. The gravitational effect is negligible. So the only force acting towards the positive plate is the electrostatic force. That is 1.76 10 to the power minus 15 equal mass of the electron is given in the data sheet 9.11 10 to the power minus 31 times A. Find its acceleration towards the positive plate. That will be 1.93 10 to the power 15. 1.93 times 10 to the power 15 meter per second squared. So I know the time to complete 10 centimeter parallel to the plates. During the same time, like a projectile motion, it completed the displacement towards positive plate also h. So I can use towards the positive plate. Now s equal ut plus half at squared. So h equal, when it enters in the region between the plates, its velocity towards positive plate is 0 because it's entering parallel to the plates. So that should be 0, has no component towards the plates because it's parallel to the plates it's entering. That's the way we should take. The half into the acceleration 1.93 10 to the power 15 times the time we found it, that is 4.55 into 10 to the power minus 9 all things squared. Solve it, you will get the value of h in meters. That will be 0.02 meters or 2 centimeters. Okay, question number 5 is about Millikan's oil drop experiment. That is the experiment used to find the charge of an electron. Okay, so there the diagram is given and they are saying the negatively charged oil drops. So that means when you spray due to friction with the nozzle, the oil drops will get charged. So they are carrying negatively charged. They are negative charge. The question says, negatively charged oil drops are sprayed into a region above two parallel metal plates. The plates are separated by a distance d apart. The oil drops are allowed to enter the region between the two plates. A potential difference V applied across which causes an electric field to be set up between the plates. So there is electric field developed between the parallel metal plates. So A part, question number 5, A part. So they are giving parallel plates. This is plus volt, this is 0 volt. Okay, doesn't matter because relative to this is negative. Relative to this is positive. 0 volt. Maybe it would have connected to earth. I told whenever something is connected to earth, that potential will become 0. So say for example, if you have a parallel plates and if you connect this to a DC power supply of 9 volt, and obviously we know that certainly this plate will become positive, the upper plate will become positively charged because it's connected to the positive terminal, and the bottom plate will become negatively charged since it's connected to the negative plate. Okay, if I connect this to earth, that means this voltage will become 0. Whenever a metal plate is connected to earth, its potential will become 0, but the potential difference is 9 volts. So this will be plus 9 volt. The upper plate will be plus 9 volt. So the same setup, if I connect it like this, so this is the upper plate, same DC power supply. If it is connected like this, 9 volt, So we know upper plate is positively charged. This is negatively charged because positive plate, positive terminal, negative terminal. If this plate is connected to Earth, then this will become 0. Potential difference should be 9 because the voltage is 9. So this will be minus 9 volt. Okay, so that's the way we find it. Okay, so when we find the potential difference, maximum minus minimum. So here maximum 9 minus 0, that is 9 volt, the potential difference. Here maximum is 0, so 0 minus minus 9, that also 9 volt, the potential difference. Anyway, there are not much questions in Edexcel based on this connection of Earth, but better know that also. So here they are saying this is positive plate, this is 0 plate, means relative to this, this is negative plate. And A part, the diagram shows one oil drop falling between the plates. So there's an oil drop also given here. Add lines to the diagram to show the electric field between the plates. So certainly we know that positive, this is negative, uniform electric field. Draw at least 4 lines with equal space, and those lines are parallel to each other. Next part, B part. V is the gradually increased at a particular value of V. The oil drop stops falling and remains stationary between the plates. Explain this observation. So actually, what happens when the oil drop, those plates are kept in horizontal plane. They are kept in horizontal plane. So when you think about the forces acting on the oil drop, actually it will have weight downwards. So upper plate is positive. So the electron is the oil drop is negatively charged. Already it's given. So the electrostatic force will be upwards, and also there will be, due to buoyancy effect, there will be upthrust. But for oil drop, the upthrust is negligible. Air density is very low, and there will be drag force also. Anyway, in your syllabus, we are not considering those things. So we consider only these two forces. So when you increase the potential, what happens? Fe equal QE. Q is the charge of the oil drop, and the E equal V over D. So when you increase the potential difference across the plates, E will increase. When E increases, the electrostatic force will increase. So there's a chance these two forces can balance each other and keep the oil drop at rest in the region between the parallel plate. So they are saying V gradually increase at a particular value of V, the oil drop stops falling and remains stationary. So at that instant, we can say the electrostatic force is balanced by the weight. So then drag force won't be there because it's at rest, but the upthrust will be there, buoyancy effect. But normally that is negligible. Density of air is much smaller, Archimedes principle. So we don't need to consider the upthrust also here. So these are the two forces acting on the oil drop. So the question is, explain this observation. So we can say like that, what I said. So when it is at rest, the weight of the oil drop is balanced by the electrostatic force. The electrostatic force is acting upward direction because upper plate is positive and the oil drop is negatively charged. That's the answer for question number 5, part B. Okay, so part C, it says the oil drop has a mass M and charge capital Q and stops falling when the potential difference across the plates is 5000 volt. Show that Q over M. Q is the charge of the oil drop, M is the mass of the oil drop. For this oil drop is about 50 microcoulomb per kilogram. So I can see, I can explain like this, because when it is at rest, Fe, the electrostatic force, is equal to mg. Fe equal QE equal mg. So they ask you to find the value of Q over m. So Q over m equal, bring the m down, G over E, but E equal V over D. So substitute that, E equal V over D, you will get GD over V. Substitute the values, 9.81 The distance between the opposite parallel plates is given as 2.5 centimeters. So 2.5 into 10 to the power minus 2, and the potential difference is given 5,000. Solve it. You will get the answer for this one. You will get 4.9 10 to the power minus 5 Coulomb per kilogram. But they also show that 50 microcoulomb. So if I want a converter, 10 to the power 5 I'm getting, 10 to the power minus 5, 10 to the power minus 5 Coulomb per kilogram. So micro means 10 to the power minus 6. So if I want to bring it 10 to the power minus 6, it should be 49. Is it 49? So this I can say Q over M equal 49, because 4.9 10 to the power minus 5, I can write 49 into 10 to the power minus 6. 10 to the power minus 6 is called micro, so micro coulomb per kilogram, approximately 50 microcoulomb per kilogram. Okay, part D, question number 5. The oil drop is close to another oil drop that has the same charge and mass. The oil drops can be considered to act as point charges 2.2 millimeter apart. So I can imagine the two oil drops both have same mass and they are carrying same charges. So actually we should consider from center to center 2.2 millimeter apart. They have the same charge and same mass. And mass of an oil drop is given, that mass is given as 1.0 10 to the power minus 13 kilogram. And the question is, they are like charges, they are both are carrying negative charges, so they will have electrostatic force, that is repulsive force. I can use Coulomb's law, but only thing I need to find the charge of the oil drops. I can find it because I know Q over M. Q over M, I know that. We found it in the previous part, that is 4.9 10 to the power minus 5. 4.9 10 to the power minus 5 Coulomb per kilogram. So cross multiply. The charge of an oil drop is 4.9 into 10 to the power minus 5 times mass. Mass is 1.0 10 to the power minus 13. So I will get the value for the charge of it. So charge of an oil drop will be 4.9 10 to the power minus 18. 10 to the power minus 18 Coulomb. So now I can use Coulomb's law, if equal K Q1 Q2 over R squared. K 8.99 10 to the power 9. I'll use it 9 into 10 to the power 9. Q1 Q2 both carry the same charge, so I can say 4.9 10 to the power minus 18 square, because if I multiply twice, it will be square. And the distance between the two charges will be 2.2 millimeter. So 2.2 millimeter 10 to the power minus 3 meter. Solve it. You will get the answer for the force. That will be 4.46 10 to the power minus 20 Newton. That's the force between the two negatively charged oil drops. Okay, so the force K Q1 Q2 R squared, so 2.2 10 to the power minus 3, all things squared. So the R is given 2.2 millimeter. So that's a final answer. Okay, so part E of question number 5, they're asking, with reference to the forces acting on the oil drops, explain what would happen to the oil drops if V, that is the potential across the plate, is increased about above 5000 volts. So at 5000 volt, the weight is balanced by the electrostatic force. So I already told that the electrostatic force acting on the oil drop is Fe equal QE, that is E equal BO, B over D, and this is the weight. So at 5000 volt, Fe, the electrostatic force, is balancing the weight. But when the voltage becomes more than 5000, electric field strength will increase and the electrostatic force will become more than the weight. So there will be an upward resultant force. So the oil drop will accelerate. Don't say oil drop will move upwards, you will lose 1 mark because there's an unbalanced force. When the voltage becomes more than 5000 volt, electric field strength will increase, electrostatic force will increase, and it will become more than or greater than the weight of the oil drop. So there will be an upward resultant force. So it will accelerate upward. So 3 marks. So 3 marks are given like this. 1 mark for saying when the V increases, E will increase and the electrostatic force will increase. Second mark for saying there will be a resultant force in upward direction. That is second mark. Third mark, oil drop will accelerate upwards. Don't say oil drop will move upwards, it will accelerate upwards. So I hope that will be useful to you, and I'll try to do more questions in my other videos. So until that, okay, I'm stopping this. We'll continue with some other worksheets, mostly OCR worksheets in my next video. Okay, bye.